How to implement ARIMA in R. Are you curious about how to implement AutoRegressive Integrated Moving Average in R? This method is essential for analyzing and forecasting time series data. Let's break down the steps to get you started. First, understanding the basics of ARIMA is key. The model is defined by three parameters: P, D, and Q. The parameter P represents the order of the autoregressive part, which indicates how many past values influence the current value. The parameter D is the degree of differencing, showing how many times the data needs to be difference to achieve stationarity. Finally, Q is the order of the moving average part, which tells us how many past forecast errors affect the current value. Next, you need to prepare your time series data. Load your data into R as a time series object using the TS function. Visualizing the data is important to identify any trends, seasonality, or irregular patterns. You can use statistical tests like the augmented Dickey-Fuller test to check for stationarity. Now, let's talk about R packages that are helpful for ARIMA. The forecast package is widely used and provides functions for ARIMA modeling. The ARIMA function is particularly useful as it automatically selects the best ARIMA model by testing various combinations of P, D, and Q. If you prefer to specify the model parameters manually, you can use the ARIMA function. To implement ARIMA in R, start by installing and loading the forecast package. You can do this with the following commands. Install packages, forecast. Library forecast. Once you have the package ready, you can fit the model automatically using ARIMA. Here's how you can do it. Fit ARIMA your time series data. Summary fit. If you want to specify the model manually, you can use fit manual ARIMA your time series data order is equal to C, P, D, Q. Summary fit manual. After fitting the model, it's important to check the residuals to validate the model fit. You can use diagnostic plots with the following command. TS display, residuals, fit. Lagmax is equal to 45, main is equal to model residuals. When it comes to forecasting, you can use the forecast function to predict future values. For example, if you want to forecast the next 10 periods, you can do this. Future values forecast, fit. H is equal to 10, hash H is the number of periods to forecast. Plot future values. Evaluating your model is also essential. You can compare models based on the Akaike information criterion or Bayesian information criterion, and use cross-validation or hold-out samples to test forecasting accuracy. If your data has seasonality or you want to include external variables, you can adjust your approach. For seasonal data, you can use the seasonal argument or apply ARIMA models. For models that include exogenous regressors, use the XREG parameter in either ARIMA or AutoRegressive. ARIMA has practical applications in various fields, such as forecasting stock prices, demand forecasting in supply chains, and predicting sensor data in Internet of Things devices. The automation of model selection with ARIMA makes it suitable for large-scale or real-time applications, fitting well with modern data science workflows. By following these steps, you can effectively implement ARIMA models in R to analyze and forecast time series data, utilizing R's statistical capabilities and the automation features of the forecast package.